All right, welcome back to another Ask Brian Boggs show. And I want to remind you all, if you would, I brought it up last time, and I would like to ask you again, please leave reviews at the end of this show, or even during it or before it quite ends. Let us know what you think of the show. We really need to hear from you all, and it'll help other people find the show as well. And I'd like to remind you too that each of these programs, each of these shows are transcribed, and they're on our website, chairmakers.com. So you can, if you miss anything, you can always go to that. And the questions are also, in addition to being able to watch the show again there, the questions and answers are all transcribed and they're organized according to topics. So it should be really easy to navigate. If you have a question that you'd like to have answered on a future show or during this show, you can go to askbrianboggs.com, Instagram at Brian Boggs Chairmakers, YouTube comment section, and then on Twitter at Chairmakers. So several ways to be a part of the show and participate. After the last show, we still had questions coming in about adhesives, so apparently it's a pretty interesting topic to you folks. So I want to get back to that, and I want to also talk a little bit about adhesives in general after I finish answering some questions that came in about that, because it seems to be that there's a common thread that people seem to be stuck on. Excuse me, I didn't mean that. But I'll start out with a question from Michael Schaffner. It says, what's your take on the new generation of CA glues? I think the first company was called Nexabond, but somebody's bought them out. Any experience or thought on where these glues or where these types of glues are appropriate? Michael, I have played with those a little bit. I think it was in 2013 they had a booth at the Fine Woodworking's conference. I believe it was their annual educational conference and promotional conference. Anyway, I spent quite a bit of time at the Nexabond booth talking to the guys and peppering them with questions and trying to understand what problem they were trying to address with their product. And this is what I do whenever I am interested in looking at a machine at a show or whatever problems. I want to know what are you trying to fix? What's broken in the woodworking world that you're trying to fix? And after asking the same question about 5 times in different ways, I finally got one of the guys to say that Nexabond was not generated as a glue to solve a problem. Nexabond was a glue that was developed in trying to solve the problem of a completely different industry. And it turns out it also worked well in woodworking. And that's totally fine, there's nothing wrong with that, but I don't know that it does anything radically different than CA glue, but than CA glue that we know as, for example, Instabond or other super glues that we use in the shop. One of the things that intrigued me about my conversation with them is that they were targeting this adhesive's reaction to the salts and proteins in wood, and that there was a chemical bond going on there that was unique to Nexabond. And they had some samples there of 2 pieces of wood having been bonded together with Nexabond, and I didn't even bother taking those home to test them because, one, I just assumed that they were going to be good bonds, and we have a lot of adhesives already who can readily generate a bond that is stronger than the wood's bond to itself. So I wasn't worried about whether or not it was possible to get a strong bond with Nexabond. I was more curious about whether or not Nexabond had a place in what I was doing and where might it have advantages over other glues. Their pitch is that it's a very fast bond. It's a super glue. It's a nearly instant glue. And that has as many problems as it has advantages. The problem is that you've got to be very quick about your assembly process. But one of the problems is that I found is that you have to be really careful to have a very thin layer of this material between the 2 surfaces. And I was having trouble getting a thin enough layer. And so I was testing this in joints that I was already having great success with PVA glues, and just replacing that process or that material with Nexabond and trying to get it spread thinly like they asked me to. And I was getting a much higher failure rate than I was getting with the PVA glues. What was interesting though is the in-grain bond, where the shoulder of a mortise and tenon joint butted up against the female part of the joint. That in-grain bond was amazingly strong. In fact, it was hands down the best consistent in-grain bond I've ever seen. So where you're wanting in-grain bond strength, I don't know if there's a better adhesive anywhere. Even epoxy struggles with in-grain bonding unless you allow it to soak in really well. Now, other adhesives can glue in-grain. High glue can do it, PVA glues can do it, epoxies can do it, but Nexabond does it very easily and very quickly and amazingly strongly. But overall, I think that it doesn't really solve a problem that I have ever had in woodworking. There are several glues that we choose from, hide, PVA, and epoxy, and those have a range of not only setting times, but they have a range of tolerable temperatures in which they can perform. They also have a range in the types of woods that they bond. Epoxy that we use, that oak and teak or all wood epoxy that we use, bonds oily woods better than PVA glue or high glue will. But Nexabond is, I think it's pitched as really just a fast glue. And I don't think the speed of assembly time is a problem in even small professional shops, possibly in factories, but I think the cost of Nexabond is prohibitive there. So I just don't see a future. I took home maybe 4 different samples of the glue, different thicknesses, and ended up having a fair bit of it, but I never used it in any furniture because I did not trust that I would get a good bond. And I chose those words carefully. I did not trust that I would get a good bond, not that Nexabond could not bond well. With all of the adhesives that we use in woodworking, whether it's a white PVA, yellow PVA, I mean, I can list up the whole gamut there. All of them are capable of generating a bond that is stronger than the wood's bond to itself if applied correctly and used in a way that that particular chemical or adhesive is able to do its job. And that's where the rub is. I did not mean that pun, but the way that each of those adhesives work, including Nexabond, is very specific to its formula. So, for example, in PVA glue, you need to have at least 55 degrees in the room. Your wood can't be too cold, and you have to have an accurate surface contact and a reasonable amount of clamp pressure in order for that glue to give you the strongest bond it can give you. Now there are degrees below its strongest bond that are still stronger than the wood itself. So you don't have to get perfection in order to have a PVA or any of the other glues to give you a good enough bond for most applications. So I think if you're having glue failures and you want to solve those failures with a different glue, I would try to direct your attention away from the glue and toward your craftsmanship. Because whenever we have had a scenario where a glue bond has failed, I have always been able to track it back to something in the craftsmanship that failed, whether it was clamping or temperature or all of the different things that attribute to a glue's ability to achieve a good bond. So adding a new glue that you're not used to does not necessarily mean that you're going to have a greater degree of success or greater speed or greater production. In fact, I suggest that it's a greater likelihood that improving your gluing techniques, your process, and the precision of your machining is going to have a lot more to do with your success, the strength of your bond, and the speed at which you get things done. So I wouldn't look to Nexabond or any particular adhesive to solve problems of bond strength. You've got to solve those through good craftsmanship, and there's just no getting away from that, whatever the adhesive is. And that good craftsmanship is partly about knowing how the chemistry of your adhesives work and giving that particular chemistry what it needs to do what it does. It's very rare that it is that a glue bond failure is about a chemical failure. It's us. So, I think Nexabond is a very interesting glue. I think it's worth playing with, but I wouldn't put furniture out into the world relying on the Nexabond glue unless you've spent enough time personally with it in tests, because you're creating a variable in your environment that no one can tell you about or tell you whether or not Nexabond is going to succeed within those variables. Terry Sullivan writes in and asks, I was taught to use a 2-part urea glue for bent lamination on rockers to prevent creep, but when visiting with Sam Maloof, I noticed he uses yellow glue and said he never experienced creep in any of his bent laminations. Well, Sam may well have been right. Sam has done things and gets away with things the rest of us don't. I was a good friend of Sam and really enjoyed visiting with him myself. And I know he uses a finish I would have a hard time with, but he gets fabulous results from. One of the things that to keep in mind, Sam's environment was different than most of ours. Not just that he had a great crew of hands around him to help things out, and he was a master craftsman and could do things very accurately. One variable is the humidity in that area. It was very, very low. And humidity has an impact on everything involved, both the wood's elasticity and certainly glue's dryness and elasticity. But just because one craftsman can succeed using something, that does not make it your best choice. And you might succeed using a yellow glue or PVA glue, but I would strongly recommend sticking with the 2-part urea resin glues. They are much more brittle. They will increase your odds of success. We use epoxy, and I have used Unibond 800, which is a 2-part urea glue, and they're great. You still have to mind the joints and make sure your laminations are precise and your clamping's good and all of that, but that doesn't change no matter which glue you use. So I would stick with the 2-part urea glues for that, unless you want to use an epoxy.
Thanks for sending.
Oh, yeah, thanks. Thanks for both of you for sending those questions in. Chatham Designs writes in asking about, again, from Maloof, I'll be making a Maloof dresser using box joints. I presume you mean finger joints, to join the carcass, as he did with some of his. Do you think wood glue would make the joints too tight during glue up? I'm presuming you mean a PVA wood glue. These are all wood glues we're talking about. If so, would epoxy be my best bet? Again, the wood glue or PVA glue is not a problem here, but you want each of those fingers as they come together to have a couple thousandths of an inch of space between them. That's not a visible space, and it's not going to feel like space. It's going to feel like a snug joint. But if you put a caliper on the fingers of those joints and put a caliper on the spaces of those joints, if you're really careful, you should be able to discover that there's a couple of, in a perfect fit, the fingers are just a few thousandths smaller than the space themselves. That's just the dynamic of assembly. And if you've got that and you apply glue to both parts, you shouldn't have an excessively tight fit. You should be able to put that together beautifully and get a really strong joint. I don't think epoxy is going to solve the problem. In fact, if anything, you'll want them slightly looser, and you'll need to allow the epoxy to soak into all of the fingers before assembly, whereas the PVA glue will bond quickly enough on the surface and does not need to penetrate that much. And just a reminder, in case you weren't on the last episode, the reason you need epoxy to penetrate is because it's going to penetrate. The wood is going to soak it up. And if it soaks it up too much after you've assembled, then it can pull enough epoxy away from that joint that you won't have enough epoxy material in there to create the chemistry needed to have that two-part bond action that epoxy is really good at. So I don't think your wood glue is an issue. I would caution to not use too much, so that if you get the end grain of these box joints saturated with a lot of moisture from the glue, that can cause them to swell up more than needed. But just a nice even coat on all the parts. Be sure to coat the end grain as well on those joints. The end grain in the joint, not the end grain that it will be exposed at the end. But just assemble it carefully, and clamping pressure is real critical on that. So I would stick with what you call wood glue. And thanks for that question. That was a good one. That's one that's not a joint I use a lot of, but I have had several designs where I use that, and I really like the way yellow glue performs in that. David Biddle asks, how do you protect the mating surfaces of a glue joint from a finish that you are applying prior to glue up? I mostly use a very slow drying, tried and true old-fashioned linseed oil for finish, and Titebond 2 for glue. Tried and true is a little bit of an issue in this. It's just pure linseed oil, and I have used it before. It tends to wick across and into the wood more than some other oil finishes. I've had better luck with general finishes. The Armor Seal that we use, and we use a Seal-A-Cell as a sealer. They are chemical. There's a lot of toxins in there, so if you really want to stay away from that, you can continue to use the tried and true, but you're not going to be able to get all the way up to a glue surface. If you've got a tenon, for example, that's flush with the outside of the piece, you're not going to be able to glue all the way up to that and not have some of that tried and true creep into that. It's designed to penetrate wood, and that's what it does. And so it wants to creep along any scratches or any pores along the way, and it will get up on the glue area. So even masking those joints will not help you. In fact, I would strongly advise against masking, because masking tape can leave a residue that can interfere with the bonding, not quite as much maybe as oil itself, but I would stay away from that. But one of the things that I know people have done when they're going to use an oil finish, and tried and true would cooperate with this, is you can just use a wax, a furniture wax, right around those joint areas. Furniture wax is not going to creep. It's going to hold really still. It's a paste. It's going to sit right there and allow you to pop that glue right off or clean that glue off easily. Then when you rub in the oil later, it'll blend with that wax and mix up with it, and it's just not likely to be a problem. Tried and true, if you're using that much, you probably know it's really not much of a protective finish. It's a very open finish. It will color the wood nicely, but it will hold dirt. It's not easy to clean, and while it will, in theory, dry eventually, it's not your best finish from the standpoint of durability and protection. But there's a whole lot of other economical or ergonomical, or environmental reasons to use that. So if that's the one you want to stick with, I would either just plan on spending a lot of time washing glue off, or wax those areas rather than oiling them. So, do we have another question come in?
Yeah, we have, since you're talking about finish,
okay.
We have a question that is specific to finish from Tyler. He just asks, what is your favorite all-around finish?
There is no all-around finish. It's like, what's your favorite all-around shirt, you know? It's, finishes are very specific to not only the function of the thing that you're finishing, but like glues, the environment in which you're finishing, whether you've got a booth, whether the temperature is going to allow you to get the drying that you need. We probably use, well, I'm going to say change that. We definitely use General Finishes Armor Seal more than anything. And if we were going to name any of our finishes, our all-arounder, right now that's what it would be. There are a lot of situations in which we don't have enough drying time for it to work in our schedule. There are other reasons sometimes where it's not the best choice, but given enough time, it's a finish that's given enough time. I'm talking about calendar time, so that you've got enough days. You want to give the finish a day or so to dry between coats. Other than that, it's a great finish. We get really good, rich depth from it, more so than a lot of other finishes. Now that we've learned how to handle it a little bit better, with every finish, there is a skill required in learning what that finish needs in your shop to give you the results that you want. There are technically correct ways of doing each finish that you can read about and watch videos about. But like with glues, you're creating your own unique set of variables that have to be accommodated in order to get the results you want from a finish. With temperature, humidity, and how big a hurry you're in have a lot to do with what finish is better. One of the things that we've done with the Armor Seal too is we can get 3 coats in a day. We've got a hot room that we use to dry wood in, and it gets over 100 degrees in there. It's about a 10 by 12 foot room. And for smaller pieces, we can put them in there between coats, and within about an hour and a half or 2 hours, it's dry and ready to coat again. In fact, not only is it dry, it actually dries harder in that hot room than it does in an ambient area. So there's another one coming?
Yeah. This is from Clayson Woodworks. What's your opinion on things like the domino and CNC in the modern craftsman shop? Does it diminish the skill set or enhance the craft?
Wow, that's a good question. CNC and domino. There's nothing wrong with either. They both have the potential of enhancing the fluidity with which we can produce our work, and that is nothing but good. But like all tools, and it doesn't matter whether it's a hand tool or a power tool, we have a tendency, and I'm not saying you, I'm saying we, so I'm including me in that, have a tendency to have what we make, how we make it, and how we feel about it impacted by the tool itself. And in an ideal scenario, you conceive a design, and that design, if unpolluted by your own thoughts and attitudes and tendencies, is allowed to come about through your processes purely. It doesn't matter what the process is, I don't think. But what I have seen actually happen, and this is not Domino's fault, this is the fault of that pattern that we have, is woodworkers will get really good at using a domino, and all of their furniture will be designed with the domino system, or nearly all of it. And that becomes the thought process through which one solves problems. And that tends to take you down down the domino road, when very possibly another road would be a better one. We don't use dominoes here right now. I suspect that as we get more into case goods than we currently are, it will be a welcome addition to our joinery tricks. We are very efficient at cutting not traditional mortise and tenons, but very strong taper locking mortise and tenons. And we can do things domino can't, and I like that. And that's the other thing about the domino system. It will lead you into production patterns that will make it more difficult for you to develop really good solid mortise and tenoning, in what I will call integral tenon designs that can be superior to what you can build with dominoes. It doesn't mean that the joint is, but the design itself is limited by both halves of the joint having to be large enough to house that domino. CNC, it's the same thing. It's just that when it becomes the thing that defines our thinking, and it becomes the thing that drives our way of working, instead of the designs themselves being what drives our way of working, then that's a problem. I think it's also a problem within the CNC world that more of the training focus is going toward the technology rather than a mastery of material. And so more people are able to get into the making of wooden things by knowing less about wood. And that's not a problem caused by CNC, that's a problem caused by the way that we're responding to it. But I see that as a real issue in that world. I wouldn't be a bit surprised. In fact, I would be surprised if we don't add CNC to part of what we do in the future. In fact, it already is. We farm out some plywood cutting out to a CNC manufacturer. I just don't have an issue with that whatsoever. It allows us to get more work done. So y'all, thanks so much for your questions. And we did have one question come in that I didn't respond to yet, and I would just want to say somebody wanted to see more of our products and how we make things. There's a lot of videos on YouTube right now that we've done over the years. We've got a lot of great copy, information, and photos on our website about other products that we make. So go check that out, and it might inspire questions that you want to ask us. So go to brianboggschairmakers.com or look up Brian Boggs on YouTube. You can find all kinds of stuff. So glad you could join us, and look forward to being with you again in a couple of weeks.